Okay, welcome everybody. The title of my talk is All You Need to Know to Leverage Barcodes in Your Apps. And just a brief introduction, I'm Oliver Drobnik. I've been a full-time iOS developer and blogger since January 2010. So I've got a little bit of experience with this thing. And over the past year, I've been working on a book, Barcodes with iOS, to be published by Manning. And because Manning loves you so much, you get 44% off all books at Manning.com through December 3rd with this promo code. Mobiconf for the win. And another thing, I can even give one free copy away if you tweet something about my talk with this hashtag. I will select somebody at random, and this person will get a free copy even. So this is what I was doing for the last year, digging really into barcodes, and what I learned I want to share with you, like at a 10,000 feet overview. So barcode basics. Well, let's get started with a quiz. Yeah? What do you think these two have in common? So that's me and the UPC. Anybody read my book so far? Yeah? Yeah?
I think the birthday.
Kind of, yes. Both of them had the 40th anniversary this year. So for me, that means I'm incredibly mature and know so much. And for the UPC, it means it's a very tried and true technology. So for the past 4 decades, they tried everything they could to break it. It still works. Yeah? So it's something that's really well understood. It's very inexpensive to add barcodes to packaging because you have to print the packaging anyway, so why not just print a barcode there? It's incredibly reliable because even the very first barcodes had check digits, so you could prevent mis-scanning, and more modern ones even have redundancy, so parts can be covered and you can still read the entire thing. And the great thing about barcodes is they are a passive technology. It's not something you can scan through somebody's clothes or pocket or whatever. In order for a barcode to be scanned, it needs to be held in front of a camera or a laser. So you don't have this fear of privacy leakage that you have with other technologies like RFID and so on. And scanning technology is widely available. Previously, it was kind of the domain of having a laser-based scanner at the point of sale. Now, as I'm going to show you, everybody has got a barcode scanner in his pocket if he's got an iPhone. So the very first barcode was announced in a press release in 1973, but the first was scanned 74. That's why I said 40 years anniversary. And that was the UPC, the Universal Product Code. A couple years later, the Europeans thought, well, that's actually a good idea. Let's do the same thing ourselves. So they just added a digit in front of it and called it the Europäische Artikelnummer, European Article Number. And then just 1 year later, the Japanese, if that works. Hello? There it is. No. Yeah. The Japanese took on the European article number and called it the JAN, Japanese article number. But in the end, in 2009, the whole thing got unified because, well, all these acronyms, that's really confusing everybody. It's really just a number of an item that is traded, and the thing is supposed to be working globally. And there you have the acronym that replaced the UPC, the EAN, and the JAN. And nowadays, if you're talking about a barcode, you're supposed to call it the cheatin. So don't talk about UPCs. That means you haven't read my book or haven't listened to this talk. If you want to sound smart, just call it the cheatin. The cheatin is a standard maintained by GS1 International. I'm going to explain what this is on the next slide. It's both the name for the number as well as the symbol. The UPC became the cheatin 12 because it's got 12 digits. That's how you can tell it apart from others, like the EAN and the JAN. They're called cheatin 13 because they have 13 digits. And just by adding a 0 in front of a cheatin 12, you can convert it, so to speak, into a cheatin 13. And the cheatin 8, which you sometimes see, which is a shorter version, needs special permission. So as a company you want to use this, you have to tell GS1 that you have tried everything you can in your power. Still you won't be able to fit the cheatin 13. Okay, then you may use the cheatin 8. So briefly about GS1 International, there was a big renaming of the organizations involved with the cheatin that happened in 2005. Originally, there was just one organization, the Universal Product Code Council, which basically created the UPC, and that was renamed to GS1 US in 2005. The European Association became GS1 International, also in 2005, and so that's the structure that it has nowadays. GS1 International, based in European Union, basically overseeing the entire world, and then you have national offices. And as I said, 4 years after that, in 2009, all the previously referred to UPC, EAN, and GAN were unified to just be called the cheatin. Most countries have a national GS1 office. They have 3-digit prefixes by which you can tell them apart. And the manufacturer who's based in one of these countries gets its own manufacturer prefix by adding the 3-digit prefix and then basically a sequential number that is assigned by the national office. And the product number, the manufacturer can choose themselves. So you have half is basically an assigned number, manufacturer code, and the other half is a product number that the manufacturer can choose themselves. So let's have a look at a sticker you might have seen somewhere. This is from a Netgear router. Yeah. So the first thing that's jumps out is the formerly known Universal Product Code, cheatin 12. But there are other kinds of barcodes as well. So for example, here's the model name of the router in code 39. That's another barcode standard. I'm going to mention, I'll tell you more in a few slides. There is a top assembly number, also code 39, and even a serial number, code 39. Or to look at something that you might even more likely have seen, this is the sticker on a box that contained an iPad mini. Yeah. Again, here is a Universal Product Code, cheatin 12. But here's also a part number. In this case, it's encoded as code 128. So there's yet another barcode standard. And there's even a serial number. And you remember with Apple devices, the serial number is where you have Apple Care and where you can look up technical specs and so on. And that's all on the box. So if you can read these serial numbers somehow, say with an app, or with maybe the technology that I'm going to talk about, then you can make apps. For example, one app that I've been thinking of making is one to basically just keep track of my Apple devices. And when I get a new one, I would just basically scan the part number and the serial number, and then I have it like in a database. And if I ever need to know what the serial number is for a device that I've given to my employee, I can look it up. So that would be one use case for that. So let me give you a bit of understanding what the difference is between the different kinds of barcodes. So there are 1D barcodes and 2D barcodes. And a 1D barcode is one that's made up of bars and spaces. The longer lines are so-called marker bars, and it can be scanned, was able to be scanned for the last 40 years, yeah, as long as the laser beam touches all the bars. Yeah, so it can go any way, yeah, as long as it crosses all of them. And if you have a more modern scanner that's not laser-based but uses a CCD camera, that is simulating the laser beam also by going through multiple lines of the picture. 1D barcodes typically are either numeric, like the cheatin, or can also be alphanumeric, as you will see in a moment. And there's usually a caption underneath in human-readable text. because traditionally they didn't trust the technology, so they were putting the number there so that the cashier could also enter it if the scanning failed. But nowadays, you hardly ever see them do that because barcode scanning is, especially barcode scanning for 1D barcodes, is so reliable nowadays. Okay, the second kind of barcodes are 2D barcodes. And you see, I put it here as an example, a QR code. They are not made up of bars, yeah, but of squares. So you might ask yourself, why is it then called a barcode? Well, nobody so far has been able to suggest a good other name than barcode. It is, Apple, for example, calls them machine-readable codes, but it's not so easy to say like 1D barcodes, 2D barcodes. So it's kind of, yeah, that's the de facto name for it, and everybody will understand you if you call it a 1D barcode or a 2D barcode. So the smallest element in this case, not being a bar, is called a module. It's basically one of those black squares is a module. It cannot be read with a laser because there's no single path that the laser could walk over the entire barcode, so you have to read it with a CCD camera, yeah? Like you have in all iPhones. And the big advantage of 2D barcodes is you can represent any arbitrary data with them. So I've seen QR codes that were containing a WAV file of a sound recording. Yeah, could even do that. So let's have a look at the kind of barcodes that are supported by iOS. I've categorized them by 1D, 2D, and what they are able to represent. So on the very far left, you see the cheatin family, which have a shortened version, formerly known EAN8 UPC-E, and like the normal version, UPC-A 12-digit, EAN13 12 digits. They can only represent numbers. Just a year after that was introduced, some companies thought, well, what about letters if we are not satisfied with just representing numbers? So the very first, or the oldest barcode symbology that supports more than numbers was code 39. And you see there are quite a few variants. Code 39 Classic can only represent uppercase characters. You can have a check digit because the original code 39 didn't have a check digit, but if you modulo 43, the code, you see it's slightly longer, so that gives it this scanning security. And with a trick, you can even represent the full ASCII alphabet. But you see, it says barcodes are awesome here with upper and lower case characters, and it gets quite that much longer because it's using a control character to switch between uppercase, lowercase. 1981, code 128 was invented, and this had the advantage that it could represent alphanumeric upper and lowercase right out of the box, and you see it's much shorter. And that's the reason why companies like Apple like it, because it's less visual noise. You have shorter bars with similar content. And a year after that, the people who invented code 39 figured, well, we can do that too. Yeah. So code 93 is like a successor to code 39. Yeah. It's similar in density to code 128, but you see full ASCII still fails to reach the narrowness of code 128. So, well, if you're going to represent alphanumeric things with a 1D barcode, you probably would want to use code 128. Yeah? So a couple of years after that, the first 2D barcode was introduced. You remember from the previous slide, I told you 2D barcodes are made up of modules. Well, this is an exception. PDF 417, the PDF doesn't have anything to do with Adobe's portable document format. In this case, it's called portable data file. Yeah? Nothing to do with Adobe. And this this came into existence because somebody smart thought, well, if I have a very long line, couldn't I just wrap that, like have multiple lines? And that's what PDF 417 is essentially a 1D barcode, but wrapped into multiple lines. Yeah, so it's kind of, it has a special situation. It is a 2D barcode because it has a vertical and a horizontal dimension, but it's essentially a linear wrapped barcode. 3 years later, a Japanese automobile manufacturer introduced the QR code. They were using it mostly for tracking automobile parts in a factory. It basically got really popular because people were using it for URLs on posters. Even in Europe, that's starting to take off. And the final 2D barcode symbology that's supported by Iris is Aztec, which is very much used in tickets for planes, trains, and so on. Yeah. These are the kinds of barcodes that are supported by iOS. Naturally, there are way more, but those are probably the most important ones, and that's the reason why Apple chose them for inclusion in iOS 7. So let's touch a bit on barcode scanning itself. For barcode scanning, you will use AV Foundation, and AV Foundation rests upon 3 lower-level APIs or SDKs, frameworks, if you will, Core Audio, Core Media, and Core Animation. And of these, Core Audio and Core Media are C-based, so Core Foundation, memory management you have to do yourself, whereas AV Foundation and Core Animation are Objective-C based. So that's very useful or handy for us developers, not having to drop down to these lower levels, but we can basically do all our things in AV Foundation. So the next graphic is essentially something that you find the sample code for in my book. I will also refer to a couple of other samples from my book. All the sample code is available for free at my book's website, manning.com/Drobnik. So you can download it, play with it, yeah, no charge. Yeah. But if you buy my book, obviously, then you also have the explanation of how this whole thing works. So like as a top-level overview of what's involved in scanning barcodes, well, you first need a camera. Yeah? iPhone has like a front camera, a back camera, and this camera is represented by AV capture device. Now, the camera by itself, you need to somehow connect to other components. And this connection, think of the camera like you have a camcorder in your hand. You need to plug it into something, so you have like a cable, Firewire or USB. Yeah? And this cable is represented by UV capture device input. And if you connect the capture device input with a camera, you get 2 ports. One has metadata information, which we don't care so much about, but the port we care about is the one that delivers the video from the device. Yeah? Now, in order to interact with such an input, so sort of you have the camera, you have the connection, and you need to plug it into some sort of mixing board, you could say. And this mixing board is represented by AV capture session. And AV capture session's main task is to connect inputs with outputs. Yeah? So at the moment, we only have an input, so we don't have any kind of connections that are cross-linked. But as soon as we add a still image output, yeah, and that's the book chapter 2 sample is basically just a still image camera, which takes the video from the camera and creates a static still image from it. And you see, as soon as you add this as an output to the capture session, the capture session creates a capture connection, which connects the still image output with the video port of the device, or rather the device input. At this point, we could take still images, but we still don't see anything. Yeah? You would have like a white or black screen. And in order to remedy this, there's AV Capture Video Preview Layer, a component that comes from Core Animation. And here, you don't add it as an output to the session, but rather you set the session property of the video pre-layer to be the capture session. And as soon as you do that, you get a live video preview. Now, something that makes this a little more complicated is accessing the camera needs authorization by the user. In iOS 7, all iPhones that were sold in China already had this functionality that users had to approve access to the camera hardware. But Apple liked that so much because of the privacy that it gives people that they enabled it in iOS 8 for all apps and on all iPhones worldwide. There are 4 kinds of authorization status. The starting state is not determined. You can request authorization from the operating system. You will get a pop-up that says, do you want to permit this app to access your hardware? And once the user has done that, what's happening? Okay. Once that happens, the status changed to authorized. Now everything is fine, you can use the camera. But there are 2 other states you also have to be mindful about. The user can deny access. Then your app is out of luck. You only get a black video. Yeah? So in that case, you would have some sort of UI telling the user, unfortunately, you have to enable camera access for barcode scanning to work or for video capture to work. It's the user's choice in this case to go into the privacy settings and allow that. There's yet another status which is even more painful because it's a higher power's choice. And the higher power in this case might either be the parents of the user or the IT department that has disabled access to camera hardware altogether. Nothing the user can do in this case. So in both cases, you should be dealing gracefully with the loss of functionality if you don't get access to the hardware. Yeah? Now, getting back to this sample app was basically a still image camera, but we want to scan barcodes, not take still images. So let's remove the still image output, and actually let's replace that with AV capture metadata output. You see it's similar connected. It still creates a capture connection between the video port and the output. The one thing that's different here is you have an additional metadata objects delegate, which informs your class that you set as the delegate whenever metadata objects are encountered. And you can specify what kind of metadata objects you are interested in. And there are 3 kinds of metadata objects. Yeah? There are faces that has been in existence since iOS 6. There are 1D barcodes, and there are 2D barcodes. And faces, iOS 6, 1D barcodes, 2D barcodes became part of the whole thing as of iOS 7. There was no change in iOS 8 regarding this. So there are some takeaways I'd like to share with you. The delegate for the metadata objects is being called separately for both faces and barcodes. So if you wanted to have an app where you can detect both faces and barcodes, you'd have to basically track, is this now giving me faces, or is this now giving me barcode objects? You should use a background queue if you do CPU intensive work with these barcodes. You can set any queue you like. The easiest is to just set the main queue, but if it's CPU intense, you should use your own queue. Some restrictions, you can only scan 1D barcode at a time. 2D barcodes, you can recognize up to 4. So you could if you have a piece of paper that has 4 QR codes and you point the camera at that, you get all 4 recognized. Except for PDF 417, because I already told you before, it's kind of a special thing with the wrapped lines that counts as a 1D barcode in the detection engine that Apple provides. And the performance is much better if you scan for less things. So you shouldn't make the mistake of scanning like for everything, but rather have, and that's my last point, you should optimize the UI for the use case. Like if you have an app that's scanning product barcodes, then it doesn't make sense to use the entire preview as an active scan area, but rather you would probably restrict it to a certain rectangle of interest where you might even display a horizontal red line as to kind of tell the user this is where you want to scan the 1D barcode. Whereas with a 2D barcode, you might have like a square that's overlaid over your video preview as to communicate to the user, this is where you want to put the QR code in, that it can be recognized. Next thing I want to talk about is barcode generation on iOS devices. One question you might ask, why would you want to do that? Yeah, you have computers, you have websites that can create barcodes. Why do that on a mobile device? Well, one use case I've encountered is you might want to display a very nice and crisp cheatin barcode for a product you have scanned. Yeah? One example was somebody making an app for beer lovers. Yeah? And he would want to show the original barcode as it's on the beer, but without having to, I don't know, making a unsharp picture. He wanted to generate it as a crisp version. Another possibility is to do things like passbook, use a QR code as data transfer medium between two iPhones. So one generates a dynamic 2D barcodes, the other uses the barcode scanner to scan it. That might be one scenario. Or the other thing is iOS supports AirPrint. So what you could do is create a sheet of stickers with the URL of your, say, homepage, and each such sticker you could put on your business card. So everybody's got that, and you can do that like on the fly on a mobile phone. Why not? And the most or the best use case that I like most is a sheet of QR stickers. All of them are the same, but there's the use case that you might only want to print a single one. Like you have a hardware inventory app. Say I'm at IT department and I want to affix a serial number sticker onto a piece of hardware. Yeah, I just want to print one such sticker. And the way how you can do that is, as of iOS 7, Apple supports label printers, which are on the next slide. I will show you. And the biggest reason is now that you can scan so many things with an iOS device, printing your own barcodes or displaying them on the screen extends the scannable universe without limit. Yeah? Everywhere you can put a sticker on, you can add a QR code or a one-dimensional code, and the thing becomes scannable, and the user doesn't have to input numbers or something. I can think of many good use cases for that. Like if I have a book, yeah, in my library, and I want to put in like a serial number, this book is owned by Oliver, and if I'm giving this to somebody to read, I could scan this serial number, and then I know, this book I've handed to a friend for reading. So these are some scenarios. Now about 2D barcode generation, again, there's a sample app for that, QR Builder, which does exactly what I explained before, make a QR code of arbitrary text, and then creates an entire sheet of stickers from that. 2D barcodes are generated in iOS with core image. Unfortunately, there's only support for generating QR codes. So the generators for Aztec and PDF 417 exist, but they are private APIs. It creates a CI image, core image. You need to render that into a CG image and then scale it, because what it does is one module of the QR code, for example, is 1 pixel. Yeah? And that's way too small to use, so you need to scale it up so that each module is like 10 pixels across. Yeah? And my remote doesn't like me. As I mentioned before, Aztec or PDF 417 are private APIs. Verbindung verloren, okay. do it here. Private APIs, if you want Apple to change that, unfortunately you have to file a radar. Apparently not enough people wanted to generate PDF 417s or EdSticks, so it's still private, undocumented. So about 1D barcode generation, unfortunately there's no public APIs in iOS for that. There is a private API introduced in iOS 8 for code 128, but well, nothing official there, but don't worry, I got you covered. Yeah, I created something that's called Barcode Kit, which is free for all owners of my book. Yeah, it draws to bitmap or PDF contexts, and then the beamer goes to sleep again. And it supports a wide variety of barcodes. The one that I put in red here are the ones supported by iOS. So with this, you can create all kinds of barcodes that you like. And here's the reason why you would want to create 1D barcodes. These are the label printers I mentioned before. They are very inexpensive, about $70, $80, I think. 80 euros or so you pay for a printer like that. They have two kinds of media. They are either endless or die-cut. Die-cut means you have pre-sized labels on a foil where you can fill, basically, and they have round corners. The endless ones, you have to calculate the cut-off length, and then it can be 2 centimeters in length or 10 centimeters in length, you decide. Yeah? So if you have a very long alphanumeric one-dimensional barcode that can be like 1 meter in length, yeah? Not quite practical, but you could do it if you wanted to. One problem though with label printers, there are thermal printers. So you have an effect that's called thermal bleeding. That is, if you draw a black line, it gets, because of the thermal effect, you cannot restrict that to an exact width. Yeah? So very small barcodes, the bars get too wide. And that's something that I built into Barcode Kit, that you can reduce the bar width in that case so that you still get scannable codes out of that. Label printers have paper sensors that report the size to AirPrint. And pardon the pun, but they are endless fun. Now, last thing I want to cover in this talk is product information, because now that you are able to scan cheatins, that doesn't mean you can do something with them, because they are just a number. Yeah? But you have to imagine me researching barcodes and barcode scanning and all the capabilities around about this time 1 year ago. And so my first thought was, hey, devices have mobile internet. So one thing you could do is you could query web services that allow you to find products by cheatin. And in this example, which is the Chapter 6 sample app, I'm using a service that's called Discogs, which is a free-to-use crowdsourced database of music media. And this app is basically presents a barcode scanner. When you push the plus button in the upper left, you scan a CD, and then from Discogs it gets the artist name, what kind of media this is, like a CD, and even the band, yeah, and puts them in a table view. One problem there though is because it's user-contributed data, and the makers of few databases understand that the cheatin is really just a number. So one thing that I've seen in Discogs is user inputting the cheatin 12 or cheatin 13 with spaces. Yeah, space is of no use. Yeah, it's just because the marker bars are there that they put spaces there. And so some barcodes might have these spaces, others don't. Some are cheatin 12, some are cheatin 13. But on Discogs, you have to know the exact text string. Yeah? So that makes it sometimes hard to find something. Yeah? So if I were to do a database of cheatins, I would normalize the numbers into, say, cheatin 13. Yeah? That's kind of the global standard nowadays. Yeah? So there is no reliable source of product information on the internet. Even the standards body, GS1, only has manufacturer info. They have the addresses and the prefixes of manufacturers, but they don't know the codes that the manufacturers assign to individual products. One of you might have the idea, as I had last year, well, the biggest company that has product information on the internet is Amazon.com. Guess again. Because that was exactly what I was thinking. I implemented over a course of a week an API wrapper for the Amazon product advertising API. I was able to scan barcodes. I was able to get like book titles and stuff. And then one fine day, after I had achieved all these technical things, I came across the Amazon.com product advertising API license agreement. Unfortunately, there it says, you will not, without our express written approval, use any product advertising content in apps designed for mobile phones. Now, one argument you could bring forward nowadays, the iPhone 6 Plus, is that really a handheld device? Yeah. But that's the problem here. This legalese basically prohibits any use of Amazon information in mobile apps for whatever reason. So I was kind of stuck at the end of last year, and I figured as an engineer, well, there must be a solution for that. And so this is what I want to introduce to you on my last two slides. The service that I came up with and founded as a startup is called Product Layer. It's basically the missing product layer that you wish you had for any kind of app that would scan barcodes. So that you can just simply scan a barcode, query some product information, and create nice apps out of that. I promise there's just this one slide with information about that. Yeah, not as to overdo the marketing. It's a free JSON and RESTful web service. We have an iOS SDK on GitHub, which is open source. So you see there's no magic in there. The magic is all on our servers. So far, we have 1.7 million products. We have standard categories for products from GS1, but we have supplemented them with additional subcategories. Like there's an official category, book, but we also have all the subcategories like comics, novels, and so on. You can build any app you like with it. We'll even help you promote it. And the idea is that all users of apps that you will be building contribute back to the service. So to give a simple example, if somebody scans, say, this book, and this is not yet in our database, the user will be asked, well, we don't know what this is. Can you tell me the category? Can you tell me the title? So the second user scanning it somewhere else across the world will already have that. And so multiple users work together to refine the data. So that's the basic idea. We also are doing an API for lists. So if you think about the wish list you might have on Amazon, yeah, we have an API for that. So if the user logs into our service via your app or via a website that implements our API, he will get access to all the products he put on his wish list, and then he's no longer only stuck with Amazon to buy the products he has on his wish list, but he could also have them like on a smaller shopping website, or you could make an app just to really have a nice UI to your wish lists. Yeah? So go to developer.productlayer.com to sign up for a free account. And one thing that I didn't tell you so far is I am the developer evangelist. So if you have any kind of questions, you can ask me about that. And that brings me to the end of my talk. Yeah? Thanks for watching. You can find me at Coconetics. That's where I blog and tweet about my development work, and at Product Layer, where I'm the developer evangelist.